We're asked to determine the interval of continuity for the given function over the interval from 0 to 2 pi radians, where the interval is closed on 0 and open on 2 pi. We have f of x equals tangent of sine x divided by natural log of 2x divided by pi. Well, first we know division by 0 is undefined, so the first condition of continuity is that natural log of 2x divided by pi can't equal 0. And now for a quick review, I have the graph of the natural log function shown here on the right. Notice how the inputs must be greater than 0, so x is greater than 0, and also notice how natural log 1 is equal to 0, which is indicated by this point here. The reason I mention this is if we state that natural log of 2x divided by pi can't equal 0, this implies that 2x divided by pi can't equal 1. And again, the set of inputs, in this case 2x divided by pi, must be greater than 0. So the second condition that must also be true is 2x divided by pi is greater than 0. Now looking at the numerator, we might be thinking there's going to be some restrictions because of the tangent function, but notice here we're taking the tangent of sine x, and the possible outputs of sine x we know are on the closed interval from -1 to 1, and the tangent function is continuous over this interval, so there are no other restrictions for continuity. So let's first solve 2x divided by pi doesn't equal 1 for x. To solve for 2x, we would multiply both sides by pi. Simplifying, we have 2x can't equal pi, dividing both sides by 2. We have the restriction that x can't equal pi divided by 2. And now let's take a look at the second restriction of 2x divided by pi must be greater than 0. Again, the first step will be to multiply both sides by pi. Well, of course, pi times 0 is still 0, giving us 2x greater than 0. Dividing both sides by 2, we have x is greater than 0. So now we know to form the interval of continuity, we need to eliminate pi over 2, and x must be greater than 0. So let's go ahead and sketch a number line. The given interval is the interval from 0 to 2 pi radians. 0 is in the original interval, but one of the conditions for continuity is that x must be greater than 0, so we make an open point on 0. 2 pi is not in the interval, we have an open point on 2 pi. We must also exclude pi over 2, so there's pi, there's 1/2 pi or pi over 2. If we wanted to, here's 1½ pi or 3/2 pi. We must exclude pi over 2. The interval of continuity is the union of these two intervals. Let's go ahead and state this. Using interval notation, we have the open interval from 0 to pi over 2 union the open interval from pi over 2 to 2 pi. I hope you found this helpful.